Hi, I'm going to present unbiased review rating with tendency-based collaborative filtering. So first, let's look at online rating. There are around 1.8 billion global digital buyers in 2018, and this number is expected to rise to 2.14 billion. This corresponds to roughly 21 to 25% of the global population. Users, when purchase product, they also write review and also rate items, and they rate item from restaurant food items to digital daily consumer goods, from shampoo to digital electronics. And these ratings are very important because they highly correlate with the purchase of the product. Highly rated items are generally appear top of the e-commerce search. Now let's talk about user item bias problem. So there may be users which actually rate products very positively, and in contrast, there can be some users which rate item very negatively. So some users can only give rating above 3, or some user can give only rating 1 or 2, which is below 3. So they are negatively biased, positively biased. Similarly, some items are generally rated very positive. For example, memory card has positive bias, and compared to some items which are always rated negatively, for example, lamps. And these bias can affect product market performance regardless of the actual product quality. So what is the proposed solution? We propose a tendency-based collateral filtering approach for removal of user bias. For this, we estimate mean and mean and item tendencies for users and items, mean and tendencies. We also basically use this technique to even predict rating for a new user item pair. However, we assume that the user on the item has rated other products, so user have rated other products other than that item, and items are that item is also rated by other users. So it's not a cold start problem. Then we can get a new user item ratings. So this approach is much better approach than simple normalization, which was proposed by Vadbudela. So the assumption I want to highlight again is there is a new user item which we have to predict a rating. Now we want this users has rated other products P1 to PM except PJ, and this item should also have rated sufficient number by other users except UI. So it's no called start problem. Then we can basically predict the user item rating for a new pairs. So this problem relies that for each user and each item we have enough sufficient users and item ratings, and then we can basically do user bias and even predict item rating for user item pair rating for new pairs. Before even predicting the user item rating, we need to get user means, product mean, user tendency, and item tendencies. So user mean is basically average mean of the all the items rated by the users. Product mean is average of average review rating of that product. User tendency is basically capturing how much positively or negatively the user rate, and item tendency is capturing how much negative or positive this item is having a tendencies. Now, using this mean and tendency, we can basically have 6 cases which can basically unbias the scores. So this is by Kachale et al., where he basically say there are 6 possible cases in which you can summarize and get the estimated user rating. If both tendencies are positive, then you can do max of mean plus tendency of each of these user and item in contrast, and then get the item. So these are the possible cases. Some of these possible cases require just on tendencies, but some of them require on both users and item tendency. You can look at the paper, 2011 paper, to get a more info about how this works. Now we use this unbiasing technique and bias this is electronic Amazon data, and see how does the unbiased rating. So you can see first of all that the rating is highly biased. There's more users who rate positive than negative. For after unbiasing, we have more kind of a normal distribution, which is more inclined to the user overall mean of the item products, around 4 and 5. So how we do a rating prediction? We first get the label pair, which has all possible users which we want to look at, and all items. We get the user means, item mean, user tendency, item tendency. Next, we basically have an unlabeled pair, and we basically get which case it fall to in the earlier cases which I discussed, and then basically get an unbiased score. Now, for a new user item pair, unlabeled pair, what we can use is the tendency bias case and it unbiased score to actually predict its new ratings, which is also dependent on the prediction case, which is reverse tendency prediction, which I will explain in the next slide, to get the final predicted score. So to get the final predicted score, depending on which category fault in the user bias case, and what is his item and mean tendency. These are the six possible cases, and each cases also have some cases. For detailed proof of these, you can look at the paper. We did experiment and analysis and basically look at four things. First is, does our technique help in removing user item pairs on the label pairs? Secondly, can we predict the rating for the new user item using our technique? Secondly, does thirdly, we want to look at, does it also help us in detecting anomalous users which are highly biased or anomalous item which are highly biased? We also look how are these anomalies are correlated on contrast with the text sentiment which is given by the users, hence validating our approach that these users and items are biased in nature. We also compare them with our predicted rating and the given predicted rating by the user. So we use two data sets, which is electronics, which is 300K, label 3075K. We also prune it to have sufficient user and sufficient items so that each user is rated by sufficient number of items and each item is rated by sufficient number of users. Similarly, we also run on fine foods. So we calculate four metrics on the unbiased rating to see how much on our unbiased and predicted rating, basically to see how much uh, we are able to get close to the given ratings. So you can see that we are able to get average error, means stand SE and RMSE very close to 0 and 1. So this means that our rating prediction method is giving estimated rating very close to the original given ratings. We also see that does these ratings correlate with well with the summary of the users. So we find that some of these correlate well definitely with the ratings, and they are more closer to the text sentiment than the given ratings also, some of these. So although there is RMSE error with the given rating and the predicate score, but compare when we look at text of some of these which has huge gap, we found that our rating is much closer to the review text. We also look at outlier detection, which is basically difference between the actual score and the predicted score, and see the tail of these where the review ratings are there. So this is the left side is for the electronics and right side is for the food reviews. They look very similar. This is what we got from the outlier detection. We were able to identify user and items, which is anonymized in this case, which are highly biased or and are according to our algorithm. And we also analyze some of the reviews which are there in the paper to show that they are actually giving positive and negative ratings. And in the conclusion of future work, we want to say that we propose a new way of looking using tendency-based filtering to unbiased user item ratings, to predict new pair rating, and also detect anomalous outliers. In future, we want to analyze this algorithm on on versus sensitive attributes like race, genders, and other demographic, to see whether according to race the positive and negative bias differ, and how according to gender and also on the location how things differ. We also want to incorporate user text in doing this unbiasing, which we haven't done yet. We just use the text to see the effect of unbiasing, but we haven't incorporated that in the unbiasing algorithm. And this might help us to elevate the cold start problem which we are having in this our work.